Imagine descending into a world where light is no more than a fading memory, where shadows lengthen into eternal twilight, and the rules of surface life seem to dissolve into something alien, unfathomable. This is the ocean's twilight zone, a place between 200 and 1,000 meters below the surface, where sunlight struggles desperately to penetrate and darkness reigns supreme. Here, life clings on in strange, fragile forms, adapted to a realm so foreign that it sustains mysteries as deep as the abyss itself. Though this layer blankets nearly 60% of the planet's surface and holds about 20% of the ocean's volume, it remains one of the least understood frontiers in marine science. What creatures lurk in these dim waters, and what secrets do they guard beneath the curtain of fading light? These questions beckon as we prepare to journey into a world where every shadow might conceal an unspeakable wonder or horror. This twilight zone is no mere stretch of dark water, but a dynamic realm where day and night blend into one unending dusk. Here, faint traces of sunlight filter down, just enough to cast ghostly silhouettes but never enough to color the sea. The creatures that inhabit this zone have evolved unique adaptations to survive in near blackness. Glowing bioluminescent lanterns, delicate gelatinous bodies, and eyes trained to catch the faintest glimmer. Among them are mysterious jellyfish, transparent squids, and fish with fangs like serrated knives, all moving with a slow, purposeful grace in a place where movement often means life or death. This is an arena of endless migration, where billions of organisms rise and fall in a grand, daily spectacle, hiding from predators or seeking food sources invisible to the human eye. Yet despite its abundance, the twilight zone remains profoundly elusive, a shadowy threshold we have barely begun to explore. Scientific expeditions in recent years have only scratched the surface of the twilight zone's secrets. Advanced technologies such as remotely operated vehicles equipped with high-resolution cameras and sensors have unveiled glimpses of this mysterious world. Delicate ecosystems woven with cyanobacteria, tiny plankton, and strange, swirling clouds of bioluminescent organisms that flicker like underwater stars. But this is a world harsh beyond imagination, where nutrients are scarce and survival demands supernatural ingenuity. Bacteria in these depths, for example, produce special molecules called siderophores to scavenge the trace metals essential for life. These unseen chemical battles shape the very air we breathe, influencing global carbon cycles and the health of the planet's ecosystems. It is a reminder that the twilight zone, though cloaked in shadow, is deeply connected to life above water's surface, and holds a power far greater than its dim light would suggest. Descending deeper into the zone, the environment grows colder, denser, more alien. Fields of marine snow, particles of dead and decaying matter drifting down from the surface, settle slowly into the abyss, feeding creatures adapted to harvest every last nutrient. As we follow this slow cascade of life's remnants, the ocean floor emerges, marked by strange formations that defy expectation. Massive burrows and tubes, crafted not by rocks but by the slow, purposeful digging of deep-sea worms, stretch out like ancient ruins built in a forgotten civilization. These creatures, often overlooked and underestimated, are the unsung architects of the abyss, engineering habitats where life can take root and flourish against all odds. But what drives these worms to build such vast and intricate structures? The answer lies in a tale of survival, cooperation, and perhaps something more enigmatic. The scale of these subterranean constructions is staggering. Unlike the delicate coral reefs of shallow seas, these worm-built architectures resemble sprawling fortresses, labyrinthine networks of tunnels and chambers carved into the sediment. They create oxygen-rich pockets that nurture microbial communities, transforming inhospitable seafloor into thriving oases. Yet there's an eerie calculated precision to the architecture, spirals, fractals, and patterns repeating with mathematical exactness. Are these designs simply instinctual, or do they hint at a collective intelligence emerging from the unlikeliest of creatures? As if responding to a silent command, the worms occasionally shift their structures, creating vibrations that ripple through the sediment like a heartbeat echoing from the Earth's crust. This is a place where nature blurs the line between biology and engineering, where the builders of the abyss may hold answers far beyond our current understanding. Strangeness deepens with the discovery of bioluminescent pulses rippling across entire worm colonies, a coordinated light show emanating from the hidden cities beneath the waves. These rhythmic flashes seem like more than random glow. They pulse in sequences that suggest communication, perhaps a primitive language spoken not through sound but through light and vibration. Scientists debate whether these signals serve to coordinate behavior, attract mates, or even manipulate other species. Such phenomena prompt unsettling questions. What if this is not mere instinct but a form of awareness, a collective consciousness harnessed by creatures built of many yet acting as one? The abyss hums with unseen frequencies, a language encoded in light, waiting for us to learn its meaning. And as the source of these pulses fades into darkness, the suspense grows. What deeper mysteries lie beneath the surface of this natural wonder? Through the lens of history, we learn the worms are among nature's ultimate survivors, evolving into formidable engineers after great planetary crises wiped clean much of ocean life. Their mineralized tunnels and biofabricated structures resemble industrial factories more than organic habitats, consuming metal oxides and excreting hardened mineral tissue. These creatures are neither mere dwellers nor passive builders. They are creators shaping the future oceans from the ruins of old. Their legacy is one of both destruction and renewal, a biological paradox where death fosters life, and the quiet abyss pulses with relentless, eerie vitality. As newborn worms spin their tunnels, glowing faintly as if welding the very fabric of the seafloor, we glimpse an ocean being rebuilt, one tube at a time, one pulse at a time. Looking forward, we can imagine a distant future where entire seafloors shimmer with worm-built megastructures, organic cities breathing with tides, alive with light and shadow. These abyssal architects construct realities invisible to surface dwellers, habitats where new species evolve, some as predators, others as symbionts or scavengers dependent on this eerie infrastructure. The ocean decades, centuries, or even millennia from now may be almost unrecognizable. A world remade by the slow, subterranean artistry of worms, indifferent to human hopes or fears. What does it mean when the fate of the future oceans rests not with giants or great predators but with humble engineers of the deep? In the vast expanse of the abyss, the question lingers, who truly builds the future? Beneath the seafloor, hidden from the curious eyes of most ocean explorers, a remarkable world of architects unfolds, deep-sea worms that construct intricate, sprawling habitats from the sediment itself. These are no ordinary worms, but master engineers of the abyss, churning unceasingly through the sea floor to create vast networks of tubes and tunnels that shape the environment in fundamental ways. Their structures serve not only as shelters but also as vital ecosystems that sustain countless other creatures. Imagine a bustling city, but beneath the ocean bed, carved meticulously by creatures no larger than a finger. How do such humble beings achieve such architectural marvels? And what drives them to build such sprawling colonies in the cold, crushing depths of the sea? The answer lies in the unique biology and behavior of these resilient, almost alien, engineers. The first step in understanding these abyssal architects is to look closely at their tubes, woven from secreted proteins and mineral composites. These tubes are far from random constructions. They exhibit remarkable strength and flexibility, optimized for withstanding enormous underwater pressure and shifting sediment. Scientists studying worms like Chaetopterus have found that the tubes have complex arrangements of nanofibrils, tiny fibers aligned to provide resistance to different forces, comparable to some of the toughest synthetic materials humans have developed. These natural fiber-reinforced composites allow worm tubes to endure both the crushing weight of the deep ocean and the dynamic stresses from water currents flowing through their worlds. Such structural sophistication suggests evolution's long and patient hand-crafting solutions that balance protection, energy economy, and growth efficiency. But it's not just about sturdiness. The architecture these worms build orchestrates microscopic worlds within the sediment. Their tubes create separate chemical pockets, microhabitats where oxygen levels, pH, and nutrient availability differ markedly from the surrounding environment. This fragmentation enables the worms to cultivate rich colonies of bacteria and microbes that perform essential biochemical cycles, recycling waste and providing nutrients essential for other creatures. In one sense, these worm habitats form organic bioreactors, supporting the foundation of life where sunlight and photosynthesis play no role. It is an extraordinary engineering feat, one where biological construction directly shapes the chemistry and biology of the seafloor, sustaining life against all odds. The scale and complexity of these benthic structures are staggering. In some cases, entire fields of worm tubes interlink to form labyrinths sprawling over meters of the ocean floor. These labyrinthine cities provide refuge and hunting grounds for a variety of species, from tiny crustaceans to larger predatory invertebrates. The interconnected tunnels act as highways and shelters in an otherwise hostile environment, allowing life to move, feed, and flourish. Capturing such subterranean space reshaping forces us to reconsider the seafloor not just as a passive backdrop but as a sculpted landscape, continuously remodeled by its inhabitants. It raises an unsettling thought. What if the worms' activities shape the very terrain of the abyss, making them the true engineers of the ocean's future? Beyond their physical structures, there is a hint of synchronization in the worms' construction efforts. Observations show these creatures coordinate their building, repairing damaged tubes and expanding networks in response to environmental stimuli. Some researchers speculate they might detect vibrations through their tubes or chemical signals in the sediment, guiding cooperative behavior that results in remarkably organized patterns. This coordination seems to create repeating geometric spirals and fractal-like formations that defy mere chance. Could it be that these tiny architects follow complex environmental cues or innate rules, producing emergent designs reminiscent of great civilizations? Such precision in the dark ocean, where evolutionary pressure is extreme, hints at something beyond instinct, an ancient, primitive form of collective intelligence hidden beneath the waves. The mystery deepens when biologists discover that these worms not only engineer habitats but also interact with minerals in their environment in astonishing ways. Some species at hydrothermal vents survive toxic conditions by incorporating hazardous elements like arsenic and sulfide into their bodies, transforming them into mineralized structures that are both protective and functional. This mineral biocompositability turns the worms into living bridges connecting biology with geology, blurring the boundaries between organic and inorganic realms. Here, biology mimics industrial processes, the worms manufacturing structures with specialized materials, building their homes from the very elements toxic to most life. Could this be a glimpse into a future where life manipulates the physical world on a profound, elemental scale? These worms and their constructions represent a paradox. Seemingly fragile yet incredibly resilient, simple in design yet astonishingly complex in function. Their efforts to engineer the sediment transform hostile ground into a nurturing ecosystem, where even in the crushing blackness and cold, life persists, muddles through, and thrives. It invites us to reconsider our assumptions about intelligence, architecture, and ecosystem dynamics far below the surface. How much can these builders teach us about survival and adaptation when faced with overwhelming odds? What secrets do their tunnels and tubes hold, waiting to be unlocked by future explorers armed with brighter lights and keener tools? Finally, as we piece together the story of these abyssal engineers, we're confronted with a profound realization. These worms are the unsung architects of a hidden world that may determine the fate of future oceans. Their relentless building and reshaping of seafloor landscapes influence ocean chemistry, biodiversity, and perhaps even the climate. In a world where surface ecosystems face rapid change and stress, the unblinking persistence of these deep-sea constructors reminds us that beneath the waves, life is busy rewriting the rules, bit by bit, tunnel by tunnel. Who truly engineers the future of the oceans? Perhaps it is not the large and the visible but the small, secretive builders of the abyss who hold the key. Deep within the crushing blackness of the ocean floor, something extraordinary emerges from the sediment. A living city, vast and pulsating, forged by the tireless labor of burrowing worms. These aren't scattered burrows but colossal colonies where thousands of worm tubes intertwine, forming sprawling labyrinths that mimic coral reefs in their complexity and scale. Scientists have dubbed them worm reefs, structures that rise like ancient ziggurats from the abyss, defying the lifeless reputation of the deep seafloor. Each tube, meticulously crafted from mucus and minerals, interlocks with its neighbors to create a three-dimensional metropolis teeming with hidden life. What force compels these simple creatures to build on such a monumental scale, transforming barren mud into thriving metropolises? As we peer closer, the air grows thick with unease. These cities seem almost too perfect, too deliberate for mere survival. At the heart of these worm reefs lies a profound ecological role. They act as oxygen factories in an otherwise suffocating environment. Worms pump water through their tubes, facilitating chemical reactions that generate oxygen from sulfides and other compounds, sustaining microbes that form the base of deep-sea food webs. This process turns dead zones, areas starved of life, into cradles of biodiversity, where bacteria bloom and attract scavengers from afar. Without these living infrastructures, vast swaths of the seafloor would remain sterile wastelands, silent tombs for fallen marine snow. Yet the precision of it all unnerves. Tunnels align perfectly with chemical gradients, channeling flows like engineered aqueducts. Could instinct alone account for such harmony, or does a deeper, unspoken intelligence guide the builders? Zoom in on the geometry, and the mystery intensifies. Perfect spirals coil through the structures. Fractals repeat at every scale, from microscopic pores to colony-spanning arches. These patterns aren't chaotic but mathematically elegant, echoing designs found in nature's grandest architectures, like nautilus shells or galaxy arms. Researchers hypothesize that fluid dynamics and sediment stability drive these forms, but the consistency across distant ocean basins suggests something more. A shared blueprint encoded in worm DNA. As currents whisper through these fractal passageways, they carry nutrients and signals, binding the colony into a single, breathing entity. What if this isn't random evolution but a emergent symphony, where individual worms contribute to a collective masterpiece? Life flourishes within these worm cities, a shadowy ecosystem pulsing with activity. Tiny amphipods scuttle along tube walls, feeding on bacterial films. Nematodes weave through pores, hunting microbes. Even juvenile fish dart in for shelter from abyssal predators. The reefs serve as waste processors too, filtering toxins and recycling organic debris into usable forms, preventing poisonous buildup in the sediment. This renewal cycle breathes vitality into the deep, challenging our view of the ocean floor as desolate. But shadows linger in the corners, unseen eyes watching, vibrations hinting at larger inhabitants stirring below. Do these reefs harbor guardians, evolved to protect their creators from intruders? Sensors deployed by submersibles capture the first hints of coordination. Low-frequency hums reverberating through the structures, synchronized with subtle shifts in tube positions. These vibrations propagate like nerves in a body, alerting worms to threats or opportunities across the colony. Chemical gradients shift in response, drawing builders to weak points for repairs, ensuring the city's immortality. It's as if the reef possesses a primitive nervous system, distributed yet unified. Scientists puzzle over the mechanism, perhaps pheromones or pressure waves, but the effect is chillingly efficient. In this dark realm, where isolation should reign, unity emerges from the depths, binding lives in eerie concert. The horror subtly creeps in as night vision footage reveals faint glows emanating from tube junctions, bioluminescent microbes cultivated by the worms, illuminating pathways like ghostly streetlights. These lights flicker in patterns, pulsing with the colony's rhythm, possibly signaling mates or warding off burrowers. Yet some pulses seem irregular, almost watchful, as if scanning the darkness for observers. Are these signals mere biology, or the first whispers of awareness in an ecosystem long thought mindless? The reef doesn't just exist. It communicates, adapts, endures. What ancient evolutionary bargain forged such sophistication in creatures blind to the sun? Through geological records, we glimpse the reef's ancient lineage, predating modern oceans, survivors of mass extinctions that scoured the seas clean. They rebuilt ecosystems from ruin, their tubes preserving fossils that tell tales of lost worlds. Today, they process carbon and metals at scales rivaling forests, quietly regulating planetary chemistry. This power evokes awe and dread, for in their indifference lies a force reshaping the abyss unchecked. Human probes disturb the harmony, eliciting stronger pulses, as if the city stirs in defense. How deep does this resilience run, and what retribution might it unleash if provoked? As the lights of our submersible fade, the worm reefs recede into shadow, their secrets half revealed, half cloaked in enigma. These living cities stand as testaments to life's tenacity, engineering hope from despair in the planet's forgotten corners. They challenge us to rethink intelligence, not as brains but as emergent patterns in the dark. Will future oceans owe their vitality to these subterranean metropolises, expanding unseen? The question hangs heavy. In the silent symphony of the deep, who conducts the orchestra, and what symphony plays next? In the abyssal depths where sunlight is a distant memory, a faint but mesmerizing glow often dances through the water, bioluminescence, nature's eerie light show, crafted by some of the ocean's most enigmatic inhabitants, deep-sea worms. Unlike the cold, artificial lights of human technology, this bioluminescence breathes with life, pulsing and flickering as if the ocean itself were alive and whispering secrets. For these deep-sea worms, light is not merely illumination but a language, a tool for communication, defense, and even seduction in a world where traditional senses blur in perpetual darkness. What kind of messages could these ghostly signals carry? Could such flickering lights represent an ancient code, evolved before eyes or ears could exist in this dark realm? A secret conversation beneath crushing pressures and immense cold? Bioluminescence in these worms is produced through highly specialized cells and organs that release light via complex biochemical reactions involving luciferins and luciferases, molecules that spark glowing bursts when they interact. For species like the Tomopterus worms, bioluminescence is often yellow or golden, a rarity in the predominantly blue-green oceanic glow, suggesting a refined, species-specific signaling system. This light is emitted in brief flashes or sustained glows controlled by neural impulses, with calcium channels regulating the timing and intensity. Scientists have discovered that these flashes can deter predators by startling or confusing them, acting like a sudden, flickering warning in the dark. Alternatively, the soft glows may invite mates, marking the location of potential partners in a vast and sparse environment. Such a duality in function, defense, and attraction speaks to the delicate balance these worms maintain between survival and reproduction in their night-shrouded world. Imagine a city of these worms sprawling beneath the waves, their tubes and burrows illuminated by coordinated bioluminescent pulses that ripple like waves through their structures. These light signals are more than random flickers. They seem to form patterns, sequences that hint at communication on a scale much bigger than an individual. Researchers have observed synchronous flashing and pulses, likely controlled by nervous and chemical pathways, that might convey warnings or status updates across the colony. The ocean floor becomes a glowing network, alive with messages encoded in light, a silent conversation undetectable to human ears but vital for the worm's social life. What if, tangled in these rhythmic glows, lie the blueprints for collective behavior emerging from the deepest shadows? Though the exact meanings of these light signals remain largely speculative, the biological sophistication behind them is undeniable. Nervous systems in these worms respond to stimuli, triggering light emission with remarkable speed and precision. Some emit flashes only when disturbed by touch or chemical cues, a startling defense mechanism that may confuse predators or attract secondary attackers to the threat. Others use continual glowing during mating seasons, creating ephemeral lighthouses in the darkness to find one another in an ocean wider than any landmass. This bioluminescent behavior likely evolved as a lifeline, a language in the void where sound travels poorly and sight is nearly useless. Could these glowing pulses represent the earliest form of social signaling, predating even vision? There is also a chilling subtlety to the spectacle. The glowing worms appear to be aware of observers, their light patterns shifting unpredictably when disturbed, almost as if watching and responding to the curious intruder. Footage captured during deep-sea expeditions shows rhythmic pulses fading to near invisibility as instruments approach, then re-emerging with alterations, a spectral dance playing out in the darkness. This synchronicity hints at a primitive intelligence embedded not in individual minds, but in the colony's collective physiology. Such emergent consciousness blurs the boundary between organism and environment, crafting in the abyss what might be called a living, thinking entity. What unseen networks might exist beneath the waves, humming with luminous thought. The ecological significance of this bioluminescent communication cannot be overstated. These worms help regulate life in the abyss by creating social structures where solitary creatures would otherwise flounder. Their lights orchestrate interactions that enable reproduction, collaboration, and survival in an environment that is hostile and unforgiving. This glowing language could map territories, denote food availability, or synchronize reproductive swarms, optimizing their chances in a realm where every glowing flash counts. Scientists continue to unravel these networks, hoping to decode the messages that have evolved over millions of years in almost total darkness. How distinct might these communication systems be across worm species, and could they hint at a shared evolutionary origin of light use in the deep ocean? Bioluminescence also plays a role in predator-prey dynamics, serving as both warning and weapon. Some worms emit spectacular bursts of light when attacked, releasing glowing bombs that distract or disorient predators, allowing escape through labyrinthine tunnels. These chemical and neurological processes underscore an ancient arms race, with light wielded as a weapon born of desperation and adaptation. In this dark cathedral of survival, light is both shield and sword, a paradox that reinforces the fragility and cunning of life deep beneath the waves. What other forms of bioluminescence might lurk yet undiscovered, and what stories do their flickering tongues tell of survival in the abyss? As the deep-sea worm's bioluminescence subsides and darkness reclaims the ocean, one question lingers. What else lies hidden in the silent shadows? The glowing signals hint at complex societies, uncharted ecologies, and possibly even emergent intelligence thriving in places human eyes have barely glimpsed. They remind us that light, even in its faintest forms, is a beacon of life, communication, and mystery in the planet's darkest corners. This interplay of biology and bioluminescence is a haunting testament to evolution's endless ingenuity, casting a spectral glow on the future builders of the oceans. And so we ask ourselves, in the cold, black depths, who truly speaks with light, and what messages do they hope we never hear? Beneath the crushing pressure of the deep ocean, life has found a way to communicate in a realm where sound travels poorly and sight is almost meaningless, through pulses of bioluminescence. These deep-sea worms are not just solitary builders but social creatures weaving a glowing network of light signals that ripple through their interconnected colonies. Unlike surface communication, their messages flicker in the darkness, brief flashes or steady glows that convey warnings, invitations, or territorial markers. It's a silent, spectral language evolving over millions of years, adapted perfectly to a world without sunlight. How might these light pulses form a complex vocabulary in the absence of eyes and ears? What secrets might hide in their bright, ephemeral flashes in the darkness? The bioluminescence produced by some deep-sea worms, like the transparent Tomoptera species, is intricately controlled by their nervous systems. These worms produce yellow light, unusual among ocean dwellers that usually glow blue or green, through specialized cells in their parapodia, which are essentially little limbs. Neurochemical signals trigger calcium channels, releasing light in precisely timed pulses ranging from quick flashes to longer glows. The worms modulate their light output depending on stimuli, switching from sudden bursts that startle predators to soft, continuous glows that attract mates or signal social presence. This ability to control both the intensity and pattern of light suggests a highly sophisticated form of communication, more advanced than mere reflex flashes. Can a deep-sea worm's glow be compared to a secret Morse code beneath the waves? In their sprawling colonies, these light signals extend far beyond individual worms, rippling through the interconnected tubes in synchrony. Researchers have documented synchronized flashing, where vast clusters pulse in coordinated rhythms, creating ghostly waves of light that travel through the worm cities. Such collective signaling likely helps maintain colony organization, alerting neighbors to threats or guiding reproductive behaviors. Imagine a vast, glowing web spanning meters of ocean floor, a communication network that pulses with life in an environment otherwise mute and impenetrable. This glowing conversation challenges our simplistic notions of intelligence and communication, hinting at emergent colony-wide behaviors that blur the line between individual and collective existence. Beyond social signaling, the bioluminescence serves critical ecological functions. Flashes can deter predators by confusing or startling them, effectively functioning as a warning light in the jaws of darkness. Some worms release luminous bombs, detachable glowing mucus, that distract attackers while the worm escapes. During mating seasons, steady glows act as beacons, enabling worms separated by vast distances to locate partners. In this way, light becomes a lifeline, bridging the immense spatial gaps in these sparse habitats. The dual role of bioluminescence, as both weapon and invitation, speaks to the delicate balance deep-sea worms must maintain to survive and reproduce. What might be the evolutionary turning points that drove such complex uses of light in these enigmatic creatures? The mysterious flickers also provide clues about the sensory world of the abyss. Worms likely perceive these signals using light-sensitive cells capable of detecting subtle brightness changes rather than detailed images. Unlike terrestrial creatures with eyes, many deep-sea worms might rely on generalized photosensitivity to track the patterns of light pulsing from their surroundings. This means bioluminescent communication probably operates on simple yet effective codes, flashes of specific frequency or duration interpreted as messages by receivers tuned to the same patterns. Could this represent one of the earliest evolutionary forms of language, based not on words or sounds but on rhythm and light in the abyssal dark? Scientists suspect this light language could govern more than just defense and mating. Bioluminescence may coordinate colony-level behaviors such as synchronized tube building, feeding cycles, or environmental response. Vibrations and chemical signals likely interplay with light, creating multimodal communication networks. These dynamics are difficult to observe directly yet tantalizingly suggest that worm colonies function as integrated superorganisms. Each pulsing light a neuron in a vast biological brain, connecting individuals into a coherent whole. Does this emergent intelligence hint at a form of consciousness far different from our own, one sculpted by darkness and efficiency, unwavering and alien? There is a subtle unease beneath the beauty of these glowing patterns. Footage from deep-sea submersibles sometimes captures light signals that respond mysteriously to the human presence. Pulses slowing, flickering, or suddenly vanishing as if the colony senses and resists intrusion. This interactive quality transforms the worm cities into living entities, aware in ways we barely understand. Are these luminescent pulses a natural defense against the unknown, or do they represent an ancient evolutionary vigilance honed in the silence of the abyss? The thought lingers like phosphorescent mist. We are not just observers but participants in a luminous dialogue with a world utterly unlike our own. As the lights fade and the abyss grows black once more, the bioluminescent signals of these deep-sea worms remain a haunting testament to life's resilience and creativity in the most inhospitable places. They remind us that communication transcends language or sound, and that even in the deepest shadows, life invents ways to connect, cooperate, and endure. These glowing architects of the abyss are, perhaps, the original builders of mysterious futures beneath the waves. What other secrets might their light conceal, waiting for us to decipher the glowing verses of the ocean's dark poetry? In the crushing depths of the ocean, where sunlight has long since vanished, mysterious pulses of eerie light ripple through the darkness, emanating from deep-sea worms that seem more like alien architects than simple creatures. These bioluminescent signals are not mere happenstance. Instead, they suggest an intricate, hidden language transmitted through waves of glowing flashes. As scientists probe deeper, they are uncovering evidence that these pulses represent a sophisticated communication network, a pulse code that travels through the worm colonies intertwined in the seafloor. Could this be life whispering secrets in a forgotten tongue? Are these signals a primitive form of conversation, or perhaps a shared consciousness stretching across many bodies? The ocean's abyss pulses with unspoken mysteries waiting to be decoded. The light produced by these worms is extraordinary in both hue and control. Unlike most ocean bioluminescence, which glows blue or green, many deep-sea worms emit a rare yellow light from cells concentrated on their parapodia, small rhythmic limbs arrayed along their bodies. This yellow glow is regulated by complex nervous mechanisms, triggered by nicotinic cholinergic receptors and calcium channels that finely tune intensity and duration. The worms modulate their emissions based on environmental cues, flashing brightly to deter predators or glowing softly to attract mates. This indicates a nuanced bioluminescent system akin to a lighting control panel in a vast, dark concert hall. It's not random blinking but a deliberate signal, shaped by millions of years of evolutionary refinement. Zooming out, the pulses of light ripple beyond individual worms, extending into the vast worm-built colonies that carpet the ocean floor. Within these living cities, bioluminescence spreads like electrical impulses across a neural network, with flashes propagating through tube systems and sediment channels. The synchronization suggests that the worm's nervous signals are not isolated but connected, coordinating defensive and reproductive behaviors in unison. These luminescent waves may serve as alarms, social calls, or territorial markers in a habitat where sound is drowned and vision limited. The notion that these worm colonies function as integrated superorganisms, communicating as whole rather than as parts, challenges conventional notions of intelligence and social behavior deep underwater. Bioluminescence for these worms serves many ecological roles. When threatened, some species release sudden flashes or bioluminescent mucus bombs to startle predators, causing confusion in the darkness. At other times, during spawning events, sustained glows act as lighthouses that guide isolated individuals toward one another, overcoming the vast spatial distances of the deep sea. These signals become critical to reproductive success and survival in this harsh environment. Light becomes a lifeline, a beacon through the void, transforming the abyss from a realm of isolation into a connected network. How might these glowing signals evolve in response to predators or changing ocean conditions? The sensory world of these worms is uniquely attuned to interpreting bioluminescent signals. Without eyes like ours, many deep-sea worms likely rely on light-sensitive cells that detect changes in brightness, rather than detailed images. If light pulses function like a form of language, then the worms decode messages through timing and intensity rather than shape, which could represent an ancient evolutionary strategy. This biological communication is thus textured and rhythm-based, akin to Morse code sent through the ocean's darkest reaches. It begs the question, could this rhythmic glow be the deepest, oldest form of language still in use by living beings today? The most captivating mystery is the emergent intelligence hinted at by these bioluminescent patterns. Worm colonies seem to orchestrate their light flashes collectively, responding rapidly to external stimuli and internal needs in a coordinated fashion. This collective response resembles a primitive nervous system spread over meters of seafloor, with bioluminescent signals conducting information like electrical impulses within a brain. Such emergent behavior hints at a level of social complexity entirely alien to us, a neural network without neurons, a mind without a brain. Could these luminescent networks be precursors to a form of consciousness vastly different from our own, sculpted by the claustrophobic depths and the economy of darkness? Even stranger is the interaction between these bioluminescent worms and human observers. Footage from deep dives shows how the worms alter their flashing patterns in response to submersibles, reducing light emissions or changing rhythms as if aware of the invasion. This reactiveness implies a level of environmental awareness and caution, an adaptive behavior that borders on conscious avoidance. In the dead silence of the abyss, these luminous patterns constitute a dialogue between worlds, a tense negotiation of presence and privacy. What else might these ancient beings sense that remains beyond human detection? As these bioluminescent pulses dwindle and vanish, darkness reclaims the deep sea, but the questions remain. The glowing signals from these worms are a faint but powerful testament to life's resilience and ingenuity in the shadows. They propose new models of communication, community, and possibly cognition in one of Earth's last great frontiers. Life here shines not by chance but by design, illuminating the pathways of survival and connection woven through the unknown. In the end, these deep-sea worm colonies may well be the original architects not just of the ocean's physical structures, but of its mysterious language, casting a spectral glow over the future of life on Earth.